No, I got you. I got you. I got you. I know. It's a rough day. No, it's not your fault. Not your fault at all. Not your fault at all.
Does Lopez, when is our next test?
Say again. Oh, did you?
Ooh, I don't know.
Oh, okay.
Like November. Don't you worry about that for now. Let me tell you. November, like the week of November 17th, probably. So in
So,
about another month.
if we
Okay.
didn't, then we'll make the take. All right. I'll call you.
All right, about 30 more seconds. 30 more seconds, finish writing. All right, so here we go, let's talk about it. So when two lines intersect, the angles that are opposite each other, we call those vertical angles. So looking at my little diagram over here, I have two sets of vertical angles. I have angle 4, angle 4 goes with angle 2, and then I have angle 1 with angle 3. Those are vertical angles. So angle 1 and angle 3 are a set of vertical angles. Angle 2 and angle 4 are a set of vertical angles. And like our theorem states, the theorem says if two angles are vertical angles, then the angles are congruent. So that's why it's telling me that angle 1 and angle 3 are congruent to each other. And then angle 2 and angle 4 are congruent to each other. So if two angles are vertical, they're going to be congruent. Any questions about that? That's pretty straightforward. All right. So based on this relationship, we can do a couple of problems where we have to calculate missing angles. So here's the first problem we're going to do together. You don't need to copy the whole picture the way it is, but I do want you to copy down at least a little diagram where you fill in the same numbers. So I have 147 degrees, 7, 6, and 5. And in this case, I want to know what are the measures of angles 5, 6, and 7, because I don't know what they are. So based on the vertical angle relationship, which angle is going to be congruent to 147 degrees? Or 46.
6.
Oops. Yeah, 6. So I know that angle 6 is 146 degrees. But then how could I possibly figure out the measures for angles 5 and angle 7? Can anyone think of a different relationship?
I don't know if this is right, but I think just add both the same angles and then subtract it from 360 and then divide the answer by 2. I'm not sure. I'm just saying.
You are perfectly correct, Jalen. Nice job. I love that you're like, I haven't really gone over this yet, but you already know because you remember those relationships we've talked about before. So yeah, all 4 of those angles are going to add up to 360 degrees because if you kind of think about it, they all are in a circle together. You know what I mean? Like a circle is 360 and all 4 of those angles make up one circle. So one way to do it would be to subtract, add up 146 times 2, subtract that from 180, and then divide that by 2. But there's a slightly faster way to do that. So notice that angle, let me highlight this. Angles 6 and angle 7 are in a linear pair. So angle 6 and angle 7 are a linear pair because they are located along the same line. So if you think about this line right here, angle 6 and angle 7 are located right next to each other on that line. So I know that those two have to add up to what?
180?
180. 180. They both have to add up to 180. I already know the angle 6 is 146 degrees. So really all I have to do is 180 minus 146, and I'll get angle 7. So what do I get here? And yes, Perla, your question is correct. 5 and 6 are also a linear pair because they're along the other line.
That's 34.
34, good.
Yeah, I got 34 too.
Awesome. So I know angle 7 is 34, which makes angle 5 also 34. So that's how I get that. So remember, if they're vertical, they're going to be equal to each other. And then the other angle, the missing angles, you subtract from 180 to get those. Any questions on this problem?
No.
Okay, I'm going to say this right now. I'm only going to say this once before it becomes an issue, but I am noticing that Alejandro and Daniel have been laughing mercilessly at their screen. Now, I don't think that geometry is that funny. I mean, I love geometry, but I don't think it's that funny. So that tells me that they're off doing something else on a different tab. And if I see that one more time, it's going to be a problem. So this is your first and only warning.
No, she spoke to me, but I told her I had to talk.
All right. Let's do another problem. Make this a little bit more interesting.
They change the schedule around.
So this is a little bit similar, but we're adding one more part to it. So we've already done this. You do not need to write these. However, let's remember what is a complementary angle and what is a supplementary angle. So can anyone read those two definitions for complementary and then for supplementary?
Complementary angles are two angles whose measures have a sum of 90 degrees. Supplementary angles are two angles whose measures have a sum of 180 degrees.
Perfect. All right. So complementary angles add up to 90. Supplementary angles add up to 180. And we already know that a linear pair, if it's on the same line, it adds up to 180. So let's take a look at what we've got here. We've got kind of a lot going on, but can anybody tell me which two
I already
lines?
figured out the answer.
Okay, good for you. Can anyone tell me which two lines are crossing? So where are the two lines that are crossing each other? AD is crossing BE. Okay.
How can you hear him, man? He's speaking so low.
I can kind of hear it. I'm like hoping that he said it right.
Say it louder next time.
Okay, so those are the two that are crossing, and then I kind of have this random ray that's shooting off from the middle. So angle or ray FC is sort of like shooting off from the middle. So that's all I know so far. So I'm gonna label all the other ones so that we can label them, so that we can figure out their measurement. Okay. So can anyone try to explain how I can possibly find the measure of angle A? Starting with angle A.
Maybe do 180 since it's like 180 and it gives us like 50 and we know the other one is 90.
Mm-hmm.
90 plus 50 and then do 180 minus 140. Yeah.
Good. So
Big brain plays.
Yeah, so I think Jalen also had the same idea. He sent it to me in the chat. But basically, since all these three angles are along the blue line, you know that angle A plus 50 degrees plus 90 degrees all has to add up to 180 because they're all on that same line. So what I can do is I can take 180 and subtract 50 and 90 from it. So what do I get when I subtract 180 minus 50 minus 90? 40 degrees. Good. So I know that angle A is 40 degrees. So with that in mind, what else can I also label?
Angle C.
Good. Angle C is also going to be 40 degrees, because what is that relationship called? What are they?
Linear pairs.
They're across from each other. They're not along the same line. They're opposite from each other. What is that called?
Vertical angles.
Vertical angles. Good. Angle A and angle C were vertical, so we know they're equivalent, they're congruent. And then what about angle B?
50 plus 90.
Good. 50. Oops. 50 plus 90. Why do you say 50 plus 90? Because those are also vertical angles. Yeah. So if we kind of ignore the green line, the green ray, we know that all of this, matter of fact, let me use a different color. All of this whole angle is vertical to angle B. So since I have to figure out what that purple angle is, I just have to add up 50 plus 90, which means angle B equals
140.
140 degrees. Nice job. So, questions on this type of problem with vertical angles? Cool. So this is only part one of today. So we've been looking at vertical angles so far. Well, now we're going to move on to a transversal line. So here's another definition. Just this sentence right here. For now. There's actually going to be, we are going to copy down this chart, but I just want to go over the definition first. So a transversal line that intersects a transversal is a line that intersects two coplanar lines at two different points. So here, my two coplanar lines, so my two lines that are on the same plane are P and Q. So these two are kind of just chilling. And then the transversal line crosses both of them at two different points. So this red line, that's my transversal line. So again, a transversal line is one line that intersects two different lines. So if you notice, what you end up getting is two scenarios where you have intersecting lines, and you're going to see vertical angles all over the place, because now it's kind of like this relationship happening two times. It happens once up here, and then it happens again down here. But now, since there's so many different locations of angles, we have different names for all of these different angles. And it's going to become incredibly important to memorize what these mean. So like I said before, I'll say it again. In geometry, we've got a lot of definitions that we just need to memorize. So there's no other way about it. So can I have a volunteer? Maybe somebody from home this time, because I've been hearing a lot from those in school. But can I have a volunteer from home read for us what is corresponding angles?
Lie on the same side of the transversal and on the same sides of the intersected lines.
Awesome. Thank you, Alejandro. Perfect. So corresponding angles are, let's figure this out, on the same side of the transversal. So if my transversal is this one in the middle, they're on the same side of it and on the same sides of the intersected lines. So in other words, here's an example. They tell us angle 1 and angle 5 are corresponding angles. So let's take a look at angle 1 and angle 5. If you kind of visualize this, you can see how angle 1, if you kind of like shift 1, 2, 3, and 4 down, they're going to fall right on top of 5, 6, 7, and 8. So when they match up, 1 matches up with 5. Can anybody tell me a different pair of corresponding angles?
2 and 6.
2 and 6, good. Which other ones are corresponding?
2 and 7.
No, 4 and 8.
4 and 8,
3 and 7.
and then 3 and 7, yeah. So I color coded it because it's easier to visualize that way. But basically you take 1, 2, 3, and 4, and if you plopped it down on top of the 5, 6, 7, and 8, you want to see which ones would line up with which ones. And that's what corresponding angles are. So go ahead. We're going to do a lot of writing definitions. Take 1 minute to write down the definition for corresponding angles. And it is very helpful. I do want you guys to write down this diagram and write down the examples from the diagram. That way you can remember what they mean when you're studying.
Sorry, in front of you guys, but
That's all right.
I'm gonna go.
I don't care. Lopez,
Yes.
does the transversal line have to go diagonally through the
Yeah. Good question. Yeah. So if you notice, P and Q are parallel to each other, and then the transversal cuts through them diagonally. So that's kind of how sometimes you can tell which one is the transversal if they don't tell you. All right, let's try the next one.
You can't do that. You gotta think about yourself. Right?
Now we have same side interior angles. Can I have a volunteer read same side interior angles?
You apply, but you never got anything back when you found the contact. That's the best thing. Yeah.
Okay, I'll go.
Go ahead.
Same side interior angles lie on the same side of the transversal and between the intersecting lines.
Good. So now we're looking at something that's on the same side of line T, but it's going to be in between P and Q. So for example, they give us 3 and 6. So I have 3 right here, 6 right there. Those are same side interior angles. And a lot of times the word for them, the name of that pair kind of explains where you're looking. So this is telling me to look on the same side, but then interior means it's in between. So that's why 3 and 6 are same side interior angles.
Could it also be 4 and 5?
Also 4 and 5, exactly. 4 and 5 would be the other pair of same side interior angles. And that's it. There's no more pairs. That's the only 2.
Question.
Yeah.
What are those little like lines there? You see, it has it in like 2 and 3 and 6.
This?
Yeah, that.
Yeah, that.
We'll go over that in the next slide, but that's telling me that P and Q are parallel to each other. That's the little symbol for parallel. All right, so go ahead. If you haven't written it already, go ahead and write down the definition and the example for same side interior angles. Okay. Moving on to alternate interior angles. So again, it's kind of telling you where to look. So let's take a moment and see what are alternate interior angles.
They're
Who
on
would
the
like to?
same side, but they're on the alternate side.
Yeah, so they're going to be on alternate sides. Let's read the definition. Do you want to read the definition?
Yes, please.
Go ahead.
Alternate interior angles are non-adjacent angles that lie on the opposite sides of the transversal between the intersecting lines.
Okay, so it's telling us opposite sides of the transversal, and they have to be between the intersected lines. So they're going to be in between P and Q, but on opposite sides. So let's take a look. They give us 3 and 5. So I'm going to erase the color coding I have already because it's going to get confusing. But I'm looking at 5 and 3. So notice they're in the middle. They're in the middle, but they're on opposite sides and they're not adjacent to each other. So they're not next to each other. They're on opposite sides and they're in between P and Q. So angle 5 and angle 3 are alternate interior angles. What is another pair of angles that would be alternate interior?
4 and 6.
4 and 6, exactly. Now, that's it. Those are the only 2 pairs of alternate interior angles. And then finally, we have alternate exterior angles. So again, it's kind of telling you, if it's exterior, that means it's going to be outside of P and Q. And since they're alternate, they're going to be on opposite sides. So who would like to read this final definition for us? Perla, go ahead.
Okay. Alternate exterior angles lie on opposite sides of the transversal and outside the intersected line.
Perfect.
Why does it sound like that?
What is what?
Why does she sound like that?
She just sounds far away because she's far away from the microphone.
Yeah.
Oh,
All right. So angle 1 and angle 7 are alternate exterior angles because again, they're outside of P and Q, and then they're on opposite sides. So what would be the other pair of alternate exterior angles?
Competition's on, man.
What would be the other pair? Yeah, 2 and 8.
Miss, I think we'll just have to yell so that you can hear us.
Yeah, you just got to be a little loud. All right, so that is all of them. So like I said, these relationships, these words, you actually have to memorize these because they will come up. So go ahead and take 30 more seconds to finish writing. And then we're going to talk even more. We're going to go in depth on each of these 4 types of angle pairs.
Miss, are we doing any math today?
Yes, we are.
Oh, I thought it was just gonna be definitions.
No, we'll do math in just a second.
Oh,
Do we have chronic
Yes, you do.
oh,
Nerds.
that's ironic.
I'm teasing. I love the way you guys are into the math, though. I really love it.
I like it.
Yeah, this is a really good group.
Yeah.
Anybody still need a minute to write? All right, cool. All right, so now we're going to go in depth, starting with the same side interior pair or interior angles postulate. So again, same side interior angles. We were looking at angle 3 and angle 6. So let me re-highlight that, 3 and 6. The ones that are on the same side of the transversal, and then they're in between P and Q. So here, let's look at this postulate. Can I have a volunteer read the postulate nice and loud?
If the 2 parallel lines are cut by a transversal, then those pairs of the same side interior angles are supplementary.
Perfect. So again, just like you had asked before, these little symbols right here tell us that P and Q are parallel. So P is parallel to Q. So I already know that because it's in the diagram. And now we can use this relationship that it's telling us. So it's telling us that same side interior angles will be supplementary. So let's take a look. If angle 4 is 70, then what is the measure of angle 5?
70?
Read carefully. We know that these two are going to be supplementary. So what does supplementary mean? And this goes for anyone. Anyone can answer this.
Equal to 180.
Equal to 180. So I know that measure of angle 4 plus the measure of angle 5 is going to be 180. So if angle 4 is 70 degrees, what do I have to do to figure out angle 5? Subtract. Exactly. So what's 180 minus 70? 110 degrees, exactly. So if you know the measure of one of those same side interior angles, you can figure out the measure of the other one by subtracting from 180. Questions so far? Awesome. So finish. I see a couple people still writing. That's fine. Keep writing. Okay. Let's go ahead and look at my alternate interior angles theorem. So there's basically a theorem for every kind of relationship. And what is my theorem for alternate interior angles? So can I have a volunteer read this one? And I know Tyrone loves to read, but I'd love to hear from someone else. Someone from home, anyone can read. Anyone going once?
Can I read?
Yes, Jalen, please do.
Read. What are you reading again? I forgot already.
The alternate interior angles theorem.
If two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure.
Same measure. Okay, so notice the difference. In the previous definition, they were supplementary, but in this definition, they're the same. So if they are alternate interior angles, they are the same. So here, I want to know if angle 4 is 70 degrees, well, the alternate interior angle, that is the pair for number 4, is angle number 6. Those are the alternate interior angles. So what do I know about angle 6? What is my measurement?
70.
Also 70, exactly. So that makes things very, very easy for us to figure out, because now I know that angle 4 is 70, angle 6 is also 70, angle 5 we had to subtract, and we got 110. So what do I know about angle 3?
Angle 3 was
110.
oh, right.
Yeah, it would also be 110 because
Alternate.
those are also alternate interior angles. So boom, just by knowing the measurement of angle 4, I can figure out all 4 of those interior angles. Questions on that? Cool, cool. What about corresponding angles? All right. Who would like to read my theorem for corresponding? Tyrone, go ahead.
Two parallel lines are cut by a transversal, then the pairs of corresponding angles have the same measure.
We can't
Same
hear
measure. I heard him.
Want me to shout like this?
Yes.
Okay, fine.
All right, so let's take a look now. Now I'm saying that if they are corresponding angles, they are the same. So remember, corresponding angles are the ones where if you take the top half and you stick it on top of the bottom half, they line up. So 4 lines up with 8, and I know that they're going to be the same measure. So how much is angle 8?
70.
Also 70. So what do I have so far? I know 4, 6, and 8 are all 70 degrees. I know 5 and 3 are all 110 degrees. Just, yeah,
I have a question.
go ahead.
So in this case, would line T be equal to 180 degrees?
Hold up, I couldn't hear because of the walkie-talkie. Say that again.
Line T be equal to 180 degrees?
Line T, any line, yeah, any line is equal to 180 degrees.
Wait, on the transversal, any line on the transversal is equal to 180?
Yes,
Because it goes straight.
because it's a straight line, right? So 5 and 6 are on the same line, line Q, so those would equal 180. 4 and 3 are next to each other on line P, so those are also add up to 180.
So line T is 180, 4 and 3 is, okay, got it.
Cool. All right. So, okay, that was my last slide. So let's look at what we've got so far. So I know this is 70, this is 110, this is 110, this is 70, this is 70. What do you guys think is going to be angle 7?
110.
Probably
Good.
110.
How do you know? What is it? What relationship can you use?
There's a
I
pattern.
can't use relationship. I'll just look at it. It's an obtuse angle, so it has to be 110.
It visually makes sense, right? But let's get used to using
And
those.
also there's a pattern.
There is, yeah, there totally is. I just want to make sure we're using our key vocabulary words. So for example, what are 5 and 7 to each other? 5 and 7.
They're in,
Dang it. Oh,
no, right?
That was the first definition we learned. It starts with a V.
Oh, vertical.
vertical? No.
Yeah, vertical.
Oh,
And
vertical?
Mm-hmm.
Hey, I was right.
You were. And vertical angles are equal to each other. So that's why I know this is also 110 degrees. What about angle 1?
70.
Angle 1.
110.
110, because angle 1 is vertical to which angle?
3,000.
3. And then angle 2 we know is
70.
70, because it's vertical to angle 4, exactly.
4,000.
So there you go, that's the pattern. Just by knowing one of those measurements, I can figure out all of the rest of them because it follows that pattern, just like Daniel was saying. So that's the cool thing about transversals. So does anyone have any questions about how that relationship works?
No.
No, not really.
Awesome, so let's do a proof. All right.
Yes.
So here's what I want you guys to copy down. I just want you guys to make this table and fill it in as we go. So you're going to copy the table and then just copy this information over on the side. So you don't need to copy the word bank. So all you need to do is copy the information they give us, and then we will fill in the table one by one. So you don't need to do all of it right now, but just set it up so you're ready to fill it out as we go along.
Miss, can I say the first answer when we're ready?
When we're ready, you may, yes.
How you got the easiest one?
I know.
That's not fair.
Fine, I'll do another one after. If Miss Lopez does. Okay, great. Then bring it to the stand.
Now notice, we're gonna fill in using those reasons, and you may use a reason more than once. So Tyrone, I know you're eager to give us the first one. What's the first one always going to be?
Given.
Given. Good. We start with what we're given. And from there, we're trying to prove that angle 3 equals angle 5. So let's keep that in mind. This is what we're trying to prove. But we need to use all of these definitions in order to do so. So first thing is P is parallel to Q, that is given. Then it tells us that angle 3 and angle 6 are supplementary angles. Now look through those definitions, look through those postulates, and let's see if we can figure out which one we can use to tell us that.
I know.
Okay, if you know it, I'm going to give everyone 15 more seconds to look through that list. And all right, so which of those definitions states that angle 3 and angle 6 are supplementary?
Same side interior angle postulate.
Good, the same side interior angles postulate. Because angle 3 and angle 6 are on the same side and they are on the interior. Okay. So far, that's all I know. Then they go on to tell me that angle 3 and angle 6 add up to 180. Let's look again at our answer choices. And let's see who can tell me. And Tyrone already went twice, so I would love to hear from a different person. Anyone can answer this question.
It says you can use it more than once, so why did you cross it off?
Oh, that's true. I could use it more than once. The only one I'm crossing off is given, because that one you are only going to use once. All right, so what do we think?
Wait, I have a wait. I don't say it's a question. Why the is like what kind of reflected?
Why does it look like it's kind of reflected? Which ones?
No, the pairs, the equal pairs. It's like they're reflected across something.
Because that's kind of what we're doing. You're totally right. It's sort of like we're reflecting things over the transversal line. So what do we think? How can I possibly tell you that angle 3 and angle 6 equals 180 degrees? Which definition allows me to say that?
Is that the definition of supplementary angles?
Exactly. And notice that we just mentioned supplementary. So in your head, you should think, okay, the next reason probably is going to be related to supplementary angles.
Alright. Split up and go in different directions.
Okay. Next up, 5 and 6 are a linear pair. Telling me that 5 and 6 are a linear pair. What do you guys think?
Linear pair theorem? No. Yes, no. No, never mind.
No?
No.
Okay.
Pull it down yourself. 101.
It's not giving a definition. It's just like, yeah.
So you're just kind of saying that they are a linear pair. And what I'll say is that in this question, given the possible answers, because we're not going to come up with anything different from what's on this list, that is the one that fits the best. Yeah, linear pair theorem.
Because it's not the equality.
And remember, we may use some of these again. So now let's think about for the next one. Now I've said that they're a linear pair. Now I'm telling you that they are supplementary. Where does that come from?
Is it
Supplementary angles? Definition? No.
Well, you might think that's right. And it looks like it's right.
It's the
Are 5 and 6 same side interior angles?
No, they're not on the same
I'm
side.
sorry.
So it's not going to be that one. Definition of supplementary would be not this one, but maybe the next one. So for
What
this
do they
one,
1 and 7 look similar?
The substitution property of equality.
for this one, I'll give you a hint. We've already used it.
Is it the linear pair?
It's the linear pair theorem again. Yep.
Oh, I did.
Because the linear pair theorem states that if two lines are located if two angles are located along the same line, they are a linear pair and they are supplementary. So the linear pair theorem kind of says two things, and both of these statements fall within that definition.
Yeah, and 4 already told you that it's 5 and 6 are a linear pair.
Right. And so now that I've determined that they are supplementary, now what do you think is going to come next? We've used it already.
Supplementary angle.
Yeah, definition of supplementary angles. Okay, so now let's take a look at what they're doing. Now I know that 5 and 6 are 180, and I also know that 3 and 6 are 180. So what did they do here? They set up an equation where 3 and 6 is equal to 5 and 6. So let's take a look. 5 and 6 equal to 3 and 6. So they kind of matched up the statements from statement number 3 and statement number 6. So what do you guys think? Which property is this going to be?
Would it be the substitution property?
Yes, sir.
Yeah, because it's substituted.
They substituted. They substituted. Rather than writing equals 180, they wrote equals measure of angle 5 plus measure of angle 6 because both of those are equal to 180. So they were able to substitute in that half of the equation. And then finally, to get what they got at the end, notice they kind of simplified that equation. What did they do to simplify it?
They subtracted
Yeah, what did they subtract from both sides?
the measure of
No.
Measure of?
angle 6.
Yeah, angle 6. They kind of eliminated angle 6 by subtracting it from both sides. So there you go. Subtraction property.
Yay.
All done. Whew. So there you go. We've done another proof. So again, with proofs, it's all about knowing what those definitions are so that you can use those definitions to prove whatever you're asked to prove. So do I have any questions on how I filled in any of these lines? Answers. Going once? Going twice? Cool, moving on. Now let's do a quick review of the definitions. Go ahead and match in your head or on your, you can write it down, you don't need to. But let's take a look and see if we understand. We're gonna do a little matchy-matchy. Take 1 minute to figure it out. Which of them are which definitions?
Wait, I'm confused. What are we supposed to do?
Okay, so we've got this diagram here. And based on this diagram, based on all those angles, which one goes where? So which of these are corresponding? Which of these are same side interior? Alternate.
The H to write the letter onto the thing for which one is that?
Yeah, so like if, let's say A matched with this, I'm not saying it does, but if it did, you would write A.
Okay, thank you.
Mm-hmm.
The answer is A now.
We'll see. Okay, 30 more seconds to think.
Oh, wait. It is. Oh my gosh, it was the answer. I mean, obviously I checked it. Yes.
10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay. Angle 4 and angle 6, what are they?
Same side interior angles.
Good. So it was A.
No, I made sure it was right. Don't
I
worry.
told you it was A.
Angle 5 and angle 8, what are they?
Alternate interior angles?
No.
Ooh, not quite.
Corresponding angles?
Vertical.
Vertical angles. Good job, Jalen. These are vertical angles because they're located right across from each other. Straight across.
That's
There's no
diagonal,
space
not
between.
vertical.
Yeah. Okay. 2 and 6.
2 and 6 are corresponding angles.
Corresponding angles. Good. Which
Last one
means
is alternative.
4
Wait,
and
I
5.
say
Yeah.
alternative? It's alternate.
Alternate interior angles. So there you go.
Let's call it alternative for now.
Alternative, like alt
Okay.
rock, alt angles.
Yeah, all angles.
All right, questions on that. This one, they made the diagram kind of sideways, but the same properties still apply.
Yeah, I maybe understand it more, except the vertical one, because it's not vertical.
Yeah, the vertical will not be right.
Verticals, just remember, vertical just means if two lines are crossing, then anything that is right across from itself, on the other side, those are vertical. So here, that's why 5 and 8 were vertical. 2 and 3 are vertical. 1 and 4, 6 and 7. That's all that means. If anything, that's the easiest one.
Yes.
Okay. So here's a few problems. I want you guys to do these on your own. This is independent work. We're going to follow the same diagram, but they're changing the measurements on you each time. So you really have to use those relationships to figure out the measures of all of these missing angles. So what I'm going to do is I'm going to put 5 minutes on my timer, and I want you guys to try and see how many you can do in those 5 minutes. And your time begins now. Go ahead.
I can do this in my head.
That's right, it's not giving out. I bet you can.
I feel more confused.
Oops, I accidentally just unmuted you guys in the classroom. I didn't mean to do that. So whoever's at the computer, if you could unmute. Thank you. A little under 30 seconds left. And what I want to do, there are 8 answers, and there's 1, 2, 3, 4, 5, 6, 7. Okay, there's 9 of us, but I know Eric's microphone isn't working, so everybody else, though, is going to be able to answer.
Eric to put one in the chat, and then I don't do it.
His chat isn't working either. He's been texting me because it's not working, but that's just his computer. All right, so that was time. Each person is going to answer one at least. You can volunteer if you'd like to, but if you don't volunteer, I will be calling on you. So who would like to go first?
Wait, for the third one?
So this is number 3, yeah. So if angle 4 is 82, what's measure angle 5? Go ahead, Perla.
Got it over with. Is it 98?
98 degrees. How'd you get that?
Oh, I did 180 minus 82.
Perfect. You got to subtract from 180 because those two are supplementary angles. Would anyone like to volunteer to do number 5? Sorry, number 4. Number 4. All right, Tyrone. So now I'm looking at angle 3 is 105 degrees. How much is angle 6 going to be?
What angle 6?
Ow.
Would it be 75?
Yeah, 75. So how did you get that?
I subtracted them because they're complementary.
Perfect. Subtracted because they're supplementary. Okay, who would like to volunteer for number 5? Daniel, I see you raising your hand. Go ahead.
Number 5. 5 would be 122. They're on opposite sides.
Perfect. They're opposite or alternate interior angles.
Yeah, so they're vertical.
Well, they're not vertical, but they're congruent.
Kinda.
They're congruent. So they're called alternate interior angles. Awesome. Janelle's, go ahead and do number 6.
She's coming, Miss.
Okay. Okay, so she says in the chat that it would be 76 degrees. So I'm looking at 4 and 6, and that is correct. They would be congruent because, again, those are alternate interior angles. All right, last 2. If you haven't gone yet, now's your chance to volunteer. Otherwise, I'm just going to call on you.
So you were off your screen.
Okay. So Jalen, Emily, Samaj. Who's going to go? Alejandro.
I didn't do number 7, but I think I did number 8, and I'm not sure of it.
Okay, go ahead and give me number 8. We'll see if you're right.
Well, I got 74 because they're both what's that word I'm looking for?
What word is he looking for? They are congruent because they are.
Start with a C, right?
It does start with a C.
Complementary?
Not complementary.
I can't think of the word.
Oh,
What is it?
corresponding? Is it corresponding?
Yeah,
Yeah,
corresponding
that
angles.
one.
I was about to say it.
All right, so those are corresponding. And then finally, I'm looking at angle 5 and angle 1. And let's have Samaj. I haven't heard from you yet. What's angle 1 going to be?
Can I do it if she doesn't do it?
Oh, wait, Samaj seems to have left somehow. Okay, I'll figure out what's going on. So, Emily, I haven't heard from you.
Oh, wow. Okay.
What's angle 1 going to be, Emily?
What I'm going to do since we lost this period, I'm going to upload an assignment.
Good. Also 109. Because they are also corresponding angles. So they match up. So that's why they're equal to each other. All right, any questions on this whole set of problems?
No, it was tricky at first, but you just have to remember your definition.
Yeah, there's only two things you'll be doing. You either have the same measurement or you subtract from 180 depending on their relationship to each other. All right, let's make things super interesting now. So this one, I don't need you to copy down the whole diagram. I mean, you can, but it'll just take you a while. So I'd prefer if you just keep your eyes on the screen and base your answers off of that. But let's read very carefully because they tell you M is parallel to N. So I'm going to draw my little tick marks, just like we had before, that tell me that line N is parallel to line M. So based on that, what I want to know is which angles are going to be congruent to angle 1. So where's angle 1? Here it is.
Ms. Lopez, I have a question.
Yeah.
Are there two transversal lines?
There sure are. So which ones are my transversals?
Q and P.
Yeah. Those are my transversals. So there's kind of two sets of relationships. So go ahead and see if you can figure out which of these are congruent to angle 1. And once we're ready for that, I'm going to put a poll up and you guys can vote on it. Matter of fact, I'll put the poll up right now. And I think everybody in school has their laptops with them, right? Yeah. Okay. The poll has an option for F. You can just ignore that option.
Oof, I picked the wrong answer.
Oops.
Do we have a specific amount of time? We have to do like
30 seconds, go.
Oh, no. Are you trying to torture me?
Oh, just use your eyes, use your eyes. This is easy. Don't overcomplicate it.
I know it.
Oh, God. Ms. Lopez, can you give me a hint? How many answers is it?
No hints.
Why?
You have 5 seconds. 5,
No.
4, 3, 2, 1. All right. Let's see what happened. So again, there was more than one answer, so don't look at, don't look at the totals. Doesn't really matter that much. But People seem to be really happy with C and pretty happy with E. So let's take a look at those two for now. So I'm looking at C and I'm looking at E. So C is angle 5, which is right here. What is the relationship between angle 1 and angle 5? What are those to each other?
I think parallel.
Close the poll.
Oh, I can stop sharing it too.
No, not you, miss. It's not you.
Oh, it's okay. All right, so again, angle 1 and angle 5. I want you guys to notice which one is the transversal. Which line is the transversal? Q. So I'm just looking at this transversal line. I'm going to ignore everything over here because that doesn't matter to me right now. I'm just kind of looking at my green transversal and then line N and line M. So 1 and 5, what are those? What's the relationship between angle 1 and angle 5?
Oh, aren't they like, I forgot to, oh no, I know.
Are they corresponding? No, right? Yeah.
They are
Oh,
Dang it.
So it's worthy.
corresponding. Because again, remember, corresponding
I created a.
when they're in the same kind of location. So in that cluster 5, 6, 7, 8, compared to the cluster of 1, 2, 3, and 4, 5 and 1 are in the same place. So they're corresponding. Therefore, C is correct.
I mean, they can start it now. They don't have much time, but they can start it now if they want.
if you want, you can move so that we can talk from our computers.
Huh?
So that
Oh, I
they
can
won't
mute
have to hear you.
Yeah, you
Yeah.
can mute so we can talk.
Yeah,
about
okay.
it.
So that they won't hear what you're saying.
And then
Go ahead.
Okay. And then E was another popular choice. So let's look at E. E is comparing angle 1 and angle 13. Now, which one's my transversal again?
Q.
Q is the transversal. P is transversal. Is there a relationship between 1 and 13?
No.
There isn't not, because here's the thing. If Q and P were parallel to each other, that would be a different story. But since Q and P are not parallel to each other, the only relationships that I can create are between this whole set of angles and then this whole set of angles. I can't cross from one set to the other set because P and Q are not parallel to each other. So it's kind of like we're separating them into two separate situations. One situation is where Q is the transversal, and then the other situation is where P is the transversal. So if I'm looking at angle 1 and angle 13, they're located in completely different like worlds from each other. So angle 1 and angle 13, there is no relationship between them. So I can't tell you whether they are equal unless they told me. So this one was actually incorrect. But do I have any questions on that? Because I want to make sure we understand that.
I got it.
Okay. Now, there were two more answers. So let's take a look at A, B, and D. So A was looking at angle 1 and angle 2. Are those going to be congruent?
No.
No. What are those instead? They're not congruent. They are?
Vertical.
They're not vertical. What are they?
Alternative.
Exterior is something.
Nope. Let's think about it. They are next to each other along the same line. What is that called?
Wait, is it like? Wait, no, it's not vertical.
They're not vertical because they're not across. They're next to each other. So these two are a linear pair.
Oh, that.
Linear pair. Remember, linear pair is directly next to each other along the same line. So therefore, 1 and 2, they're not equal to each other. They're going to add up to what? What will they add up to? It's okay, Tyrone. You can answer anyways.
There you go.
Okay, we can use
Let's
the
look
board
at
now.
it.
Yeah.
Why are you yelling,
We
Pearl?
were thinking, we were trying to say some answers. They were wrong, but.
That's okay.
We were trying. And it
That's
wasn't-
all that matters. That's good. So, okay, so let me just summarize. 1 and 2 are a linear pair, so what do they add up to?
I know you know what you're doing.
180?
They add up to 180, so they're not congruent, they're supplementary. So A was wrong. B, angle 1 and angle 3, what are these called?
Vertical?
Vertical. So are they congruent?
No.
Yes.
Wait, yes.
Yes, they are. They definitely are. So B is correct. Vertical angles are congruent. And then now I have angle 1 and angle 7. Oops. Here's angle 7. Are these congruent?
Yes.
Yeah, what are those called to each other?
Tyrone said they're alternate side. I don't remember what it's called, but
Me
you get
neither,
it,
but
right?
it's alternate something.
Alternate
Exterior.
exterior angles.
Postulate or angles. Okay.
They're alternate exterior angles, and my alternate exterior postulate tells me that they're equal to each other.
Yeah, I got it right.
So answers were B, C, and D. Nothing else. Questions on this problem?
No.
Oh,
All right.
my bottom.
At least I got one of them.
All right, let me pick. I'm going to do one more problem with you guys. Let me pick which one I want to do.
Not number 5. Number 5.
Let's do number 3 because it's related to what you're doing on Khan Academy. So here we go. In the diagram below, transversal TU intersects PQ and RS at V and W respectively. Okay. If TVQ equals 5x minus 22, so TVQ right here. If this is 5x minus 22, and oh, I think they messed this up. Hold on. Okay, this is not my question. I copied it from somewhere else and they made a typo, but I'm going to say that this is not TVQ, but hold on, let me think of which one I want it to be. RWU. This one. There we go. Okay, so ignore what it says in the problem, but if TVQ is 5x minus 22 and RWU is 3x plus 10, what value of x is going to make PQ and RS parallel? So in other words, what relationship can I set up between these two angles?
Do you mean like the substitute, yeah, that thing, I forgot the substitution.
Okay, so I can use substitution, and what equation can I set up?
3x plus 10 equals 5x minus 22.
Good. We know that they have to be equal to each other because what type of relationship do they have?
They're, what is it?
Are they all, no, they're, oh, yeah.
Alternate? Alternate what?
Exterior angle.
Exterior angles.
Miss, why is your room so cold?
I know, I'm freezing.
Keep complaining, keep complaining.
Sure.
I know.
All right, here we go. Let's solve for x. Take 2 minutes on your own. Nah, you don't need 2 minutes. You need 1 minute on your own. Solve for x. See what you get.
You have 1 minute and 30 seconds.
1 minute, go.
Dang it.
X equals 16, I think. Wait. X equals 16.
X equals 16. All right, I'm running out of time, so I am going to go through this a little quickly. What can I do
Yeah,
to both
it's actually
sides?
16.
I'm gonna
Five X.
minus 5x. 5. 3 minus 5 gives me?
-2 plus 10, and then.
You divide.
Not yet.
No.
I said,
X equals -33, I mean 32, sorry. And then you divide, and then that equals to x equals 60.
there you go.
Mental math.
This is why.
All right. So, very quickly, your homework tonight is on Khan Academy. It's okay. One assignment is very easy, and the other assignment is kind of like the one that we just did, where you have to do a little bit of algebra. So one is super, super easy, and then the other one is a little bit harder, but you guys can handle it. So that's due on Wednesday
not
at
really.
midnight. Wednesday at midnight. And that is it for today, you guys. Good job. Lots of really good participation. I want to shout out Jalen. I'm going to shout out Jalen because Jalen doesn't participate that much, but he did today, and I'm very proud of you. Good job.
What? I participate? What do you mean?
Take the compliment, sir.
Thank you.
See y'all tomorrow. Bye.
Bye, miss.
Bye.